Hello and welcome to A Gentle Introduction to Gradle. I'm Tim Berglund, a trainer, author, and speaker on Gradle and other topics. If you're watching this, I'm assuming that you're interested in learning what Gradle is all about. Maybe you know a little something about it. And you probably know something about the build ecosystem that already exists in the Java landscape, including popular tools like Ant and Maven. Now, I'm going to spend most of our time talking about Gradle itself, but there's a question I always like to answer up front. Namely,
why would we introduce another build tool? Well, there are a few reasons for this. Number one has to do with some of the tensions that the community has been feeling with the existing solutions. They're very good at what they're designed for, and each of them, those being Ant and Maven, have introduced key innovations into the build space. But as we move forward from perhaps where builds were a decade ago to where we see builds going in the next 5 to 10 years, there's a few pressures. Number one is the pressure for customization. Builds in an enterprise context don't tend to look that much like one another. There's a very simple, if you think of the simple sort of Java template for a build, which is a project I'm going to live code in front of you. We'll build a really simple Java project today. It's really easy to get that work done. But when you expand from that simple self-contained Java project to a profoundly multi-module build that spans lots of different teams and technologies, that tends to be a fairly custom thing, and actual code gets written as a part of that build. The build isn't sort of a quick and dirty little activity that helps us get on to the business of serious software development, but it's its own domain of software development by itself. And that becomes clear, nowhere clearer than in the enterprise, where there's lots and lots of custom work done on builds. And that's really the state of affairs right now. As we look into the future, from complex enterprise builds today to complex automated deployment pipelines tomorrow, and this is something that some people in the enterprise are even experimenting with right now, the idea of continuous deployment and software where there isn't just a build server that builds the code and runs the tests, but perhaps when the tests pass, does some kind of automated deployment to actual production hardware that your business relies on. When we look to that world, the future world of increased deployment automation, again, you have even more demands on the build tool and an environment really that is hyper-customized. So I hope to show you throughout the course of this webinar how Gradle delivers on the need to build simple things in an easy way, but also gives you a path, gives developers on your team a path to build custom build standards that can be anything, any sort of deployment environment or automation pipeline that you can think of. Those can be made into Gradle customizations that users of the build can think about and express in a very simple way. Again, there's always this tension between the declarative and the imperative. And this is something we're going to see in the demos that we get to in a few minutes, come out in a few different ways. It's easy to look again at the legacy Java world build tools of Ant and Maven to express the difference between a declarative build and an imperative build. A typical Ant build, which I'm sure a lot of you have seen and are used to, is a very imperative thing. To express build activity in Ant, you script a series of tasks. You describe in an imperative way what the build should be doing in a step-by-step fashion. By contrast, in a Maven build, that's a very declarative thing. And this is one of the great innovations that Maven brought to the world after Ant had achieved some popularity, which is that we didn't have to necessarily describe in this step-by-step way that could become very pedantic in a large build. You might have thousands of lines of XML in this big Ant build file saying over and over again things that you might wish to be able to express in a simpler way. Maven said, well, really what we ought to do is just kind of configure the parameters of a build and have the machinery, the actual building activity, all that imperative stuff be going on underneath, inside the engine, things Maven is doing or Maven plugins are doing. And inside the Maven POM file, we'll simply declare kind of parameters about the build and have those be interpreted by the engine. So there's this tension between the idea of an imperative build and a declarative build. And if Gradle as a technology has an opinion, it really is that declarative is where you should be. A good build is a declarative build. And that's always our goal. We don't want to see lots and lots of code in a build file, or certainly not lots and lots of XML. You know, that's not a readable thing. And a great deal of code inside a build file can be difficult to maintain, difficult for tooling to access it, and difficult to test. And there's all kinds of dangers there of putting lots of imperative code in your build. So we definitely like the declarative approach. But the problem with too much of the declarative approach is that now there's a tension between the conventions that our declarative build system will afford us and the adaptability of the build. And I hope to show you this again as we get into the demos. Gradle wants your builds to be declarative. It thinks, you know, really that was the right way to go. But if a build has to be declarative all the time, and there are few opportunities to customize the kinds of things we declare, then that implies that the build tool is going to have a strong set of opinions about what the conventions of a build ought to be. In other words, the tool is going to have some kind of abstraction that exposes to you, saying, here's what all builds ought to look like. And we'll just let you configure some parameters about how those builds run. And that works up to a point, but typically as builds become more elaborate and more complex in an enterprise environment, as software grows and as the needs of the deployment pipeline grow, the tool has a hard time keeping up with the development in the build and the complexity of the build. So while we like this idea of conventions and simple and declarative builds, we also want to make the tool adaptable, and we want to give your software development teams, or you as a developer, the ability to extend that tool and build your own brand new conventions. See, Gradle doesn't think that it can imagine all of the build conventions that ought to exist ever. It can imagine a good base set of build conventions, which it gives you. And from that point on, it gives you a toolkit to develop your own conventions and your own language to be able to describe them. And with that, it would be good if we could have a look at some actual Gradle builds. The fundamental unit of build activity in Gradle is a thing called a task. And if you're familiar with Ant, this is a lot like an Ant target, but it turns out to be a much, much richer idea. So I'm going to go ahead and break into some actual Gradle code here. And I'm going to rely on you in the questions or in the chat to let me know if you need a font size increase or anything like that. I'm going to assume that everything is in good shape. But let me go ahead and create a Gradle build. I'm going to be doing this just as a text file, no tooling yet. We'll see if we can introduce maybe Eclipse or IntelliJ IDEA a little bit later. But right now, we're just going to be playing with some basic tasks in a very simple Gradle build file. Now, the most simple Gradle build I could possibly think of would look like that. Now, of course, that build doesn't do anything. But what that does is that declares a thing called a task. A task, being the basic unit of build activity in Gradle, is also an object. And that's an important lesson for us to take a look at. Here, I'm going to, since we're in code and we're not in slides anymore, I'm just going to make a comment up here that we'll be able to take some notes in for any lessons we learn here. And the first lesson is that a task is an object, which means that a Gradle build is a program. Now, let me go ahead and run this build. It's not going to do a whole bunch. That delay is not Gradle's fault. That delay is actually an external hard drive on the presenter's computer that kicked on, and a kernel level driver there that causes that delay. So you're not going to see that startup delay again. Our apologies for that. So here we are. I've run Gradle, and let me ask Gradle to tell us what sort of tasks we have in that build. I can always ask us, Gradle, what I can ask it, Gradle, what tasks are there? And you see right here, I've created a task called Hello World. So that's a valid Gradle build. That does something. It declares this object, but now we have to configure this object and give it something to do, because by default, a Gradle task, of course, doesn't have any work to do. Now, to configure a task, we use this syntax right here. I'm going to pass it this block between curly braces. Groovy programmers will recognize that as a closure, the closure syntax. If you're not a Groovy programmer, you don't have to be. You can just kind of learn this syntax as I go along. As a part of configuring a task, I have a rich task API to access. Because remember, a task is an object up here. And this is going to remind us that a task has an API. In that API, there's a method I have called doLast. I can call that doLast method on this task object and give the task some work to do. A task, being an object, also has inside it a list of activities. Let's just remember that lesson right here. A task has a list of activities. All right, and I'm going to give it something to do. And that something is simply going to be to print out the message, Hello World. I'll go ahead and run Gradle again, but this time I'm going to tell Gradle that I want to run the task Hello World. See how much faster that startup is? Look at that. All right. So there we are. I've printed out the Hello World message, and I think everybody will agree that's totally worth the price of admission. We had a build tool say Hello World. All right, maybe you're looking for a little bit more than that. Let me give you a few more ideas in the basics of kind of build syntax and this task API, so you know the fundamentals, and then I can begin to introduce some things like how to build Java code, how to do multi-project builds, how to run tests, interesting things like that. All right, so I've declared a task. I've configured the task with stuff to do. Now, in the real world, we usually have more than one task. We usually have multiple tasks with dependencies. So let me just refactor this build a little bit. I'm going to have a task called Hello that does that. And this task I am going to have, it's going to be called World, and it's going to print the message World. So there we go. I think you kind of get the idea that I can run hello, and I can run world, and I'm going to start doing -q, which is going to, since all our builds are just printing messages out, I'm going to have Gradle suppress those lifecycle messages like this thing here and this build successful, which, you know, we all appreciate the affirmation of a successful build. But since we're just printing things right now, I'm going to do -q. That's going to get that stuff out of our hair. All right, so great. We have those two. What I would also like to do, though, is express a dependency. Before world runs, it is going to need to have the hello task run. So I could express a task dependency like that. So now when I run world, I get the hello world task running, the hello task running first, and then the world task running next. I could continue this. I could say, here's a task called hello world, and it depends on a slightly different way of expressing this, world and hello. Now I can go to Gradle. I can run hello world. I'll clear the screen again. And I forgot my -q, but I get those two tasks to run in the order that I need. I'll give you another nice little bit of Gradle shorthand syntax here. Anytime I have a task name that's expressed in camel case, like hello world, where the first letter is lowercase but words are delimited by uppercase, I can abbreviate the task name like that. That's a nice little bit of command line syntax sugar for you. Sometimes I'll come up with plugins or custom tasks that have really long names like, you know, generate change log or change log sync or something like that for some automated database deployment pipeline. And I'd much rather type something like GCW or CLS or something like that. So a really nice little shortcut to have in mind. All right, so that's the basics of the task API. And where might I go to learn more about that? Because I told you a task is an object, and therefore that object has an API. And if I could assume, I don't know all of your technical backgrounds, but if I'll assume for a minute that you basically come from the Java world, broadly speaking, and have a little bit of familiarity in that world. So if you're giving Gradle, either if you are a Java developer or if you're giving this to a team of Java developers to use, well, there's great news for them. And that is that all of this API, this whole idea of a task being an object and having methods and properties and all these things, is documented. In the default Gradle installation, we have the Gradle build language reference, or what's sometimes called the DSL, or the domain-specific language reference. We can scroll down here, and if you look off to the left, you'll see core types, and here is task. And we can click on task, and I can read about the nature and purpose of that task object. Here are a few examples of how to create and configure tasks. Like we've seen, I can scroll down. There's a nice narrative giving you a good introduction to all the basics. And then we see a list of properties. See, here's depends on. You notice I used that property. I added things to that collection, and I initialized it to be a list of dependencies. I can continue to scroll down a rich API. There's a day of detailed training, at least, in learning all this stuff. And here we have the task methods. So the details of this API are exposed to you. Notice do last. That's the method that I was calling just to have our hello and world tasks print stuff. So those things aren't magical. You don't just have to know them. They're fully documented here in this great collection of documentation that comes with every Gradle download. So please, if you're a developer, if you're giving this to developers to use, make sure they feel comfortable digging around in this stuff. I'll come back to this theme of this programming documentation existing and how we can dig into this documentation and sort of the appropriate way to think about the layers of abstraction in Gradle. And this, frankly, is a fairly low level of abstraction, right? I'm saying explicitly I've got these tasks and they have this imperative. This is the imperative build mode here. And I said before, Gradle's preference is to be declarative. So this really looks like, to me, if I were to back up a step and think about this, I would say this looks conceptually like an Ant build that I get to express in a slightly more friendly syntax. There are no angle brackets unless I want there to be angle brackets somewhere. It looks a little bit like Java. This actually technically is a Groovy-based domain-specific language. But it's still imperative. And we said before we don't like imperative. So let's see what we can do about moving towards a more declarative style in building some Java code. Now, before I make that transition and begin the discussion of plugins, I'm going to pause for just a minute and give everybody a chance to throw some questions at me, either in the chat or the formal questions interface. And I'll address those questions live before we move on to the discussion of the Java plugin. We have a guest, Shimon, that pointed out that hello world depended on world and hello. World depended on hello, but Gradle was smart enough only to run world once. And that's right. I'll point out because what's happening is before Gradle actually runs the build, and in this case, running the build refers to executing this line and this line, the two print statements. That's what this build is. So to execute this build means to print hello and to print world. But before it can execute the build, it has to figure out what the build is made up out of. It has to build a graph of these tasks. And there is another great lesson for us to learn in this task module, which is that tasks form a directed acyclic graph. So before Gradle does any execution of the build, it builds a graph of the tasks and their dependencies. It's directed, of course, because one task, hello world, depends on other tasks. This does not express that hello depends on hello world, but hello world depends on hello. And world, in turn, depends on hello, and so forth. So it's directed. It's acyclic in that you can't have one task A depending on B and B depending on A. If you try that, Gradle will slap you gently on the wrist and fail the build. If there's a cycle in the dependencies, there's no way to calculate what you should do first, and so that graph has to be acyclic. But this graph of tasks is being built up during kind of an initialization phase of Gradles. Technically, it's called the configuration phase, and I may emphasize that again in a little bit. During this configuration phase, Gradle's reading the build file, building the graph. Once the graph is built, it can come back to this command line that says, we have asked for hello world to be run. Now I can go into my graph, compute the dependencies, execute them, and actually run the build. All right. Another person pointed out the difference in syntax between this depends on left shift and depends on equals. And you're absolutely right. I did that completely intentionally. That's two ways of expressing the same thing. If you were to read in the DSL documentation, you'd see that depends on is a collection. So a task can depend on many other tasks, which makes a lot of sense. Now, Gradle, the build file syntax that I'm using here, is actually an elaboration of the Groovy language. It's a domain-specific extension of Groovy. So inside this, if you're a Groovy programmer, if you know any Groovy, I can actually write Groovy code. Hey, glad you're learning about Gradle today. This is a Gradle method definition. Now, this is a perfectly pragmatic way to kind of sketch things and make little extensions and begin to think of your build as a little piece of code that you're writing. Ultimately, you probably don't want a lot of this directly in a Gradle build by the time the build is production ready. That would be sort of like having an all-imperative build. But it's important to know and keep in mind that this is Gradle code that you're writing, so you can do this kind of thing. So this is this is Groovy code. This is one Groovy syntax for adding an object to a collection. Up here on line 14, this is a syntax for creating a list and assigning it to the collection. So this isn't adding to the dependencies. This is saying, hello world, your dependencies are these two things. And the thing in square brackets is the Groovy syntax for declaring a list. So you're right, I use those two syntaxes. Those are available to me because this is a Groovy DSL. All other Groovy syntax is available to you, which gives you tremendous power and flexibility of making a very expressive and readable build. Also, of course, some danger that instead of filling up a build file with 2,000 lines of unreadable XML, you'll fill it up with 2,000 lines of readable but untested Groovy. And through the plugin APIs of Gradle, whereby you can write your own custom plugins, that's kind of how you save yourself from that overly scripted, untested, and difficult to read build file. We want to keep the build file small, declarative, and expressing our build in terms of our own language. A question from Matthias, could I write depends on world hello? The short answer is no. No, that wouldn't work. So these two ways I've written are good ways to do it. A question from Antonia, is there a way to get rid of the initial startup penalty? Again, the startup that you unfortunately saw the first time I ran Gradle was completely an artifact of the presenter's computer. There's an external backup drive that I have that sometimes when it spins up, it makes this 5-second kind of kernel level lock on everything. So that's completely my fault for not disconnecting that before the talk. I don't want you to think that that's a part of the Gradle startup time. So the Gradle startup time that you should expect to see looks like this. That's JVM and Groovy startup time, and it's really pretty nice at this point. Gradle 1.0 has a feature in it called, enabled by default, called the daemon, which keeps kind of a live, warm-started JVM in memory ready to go. If I were to run Gradle for some reason with the no daemon option, you'd see a longer startup time, but I'm not going to do that. So again, that first startup time, pay attention every time I run Gradle. You're not going to see it be that long at all. Jeff asks, isn't the use of depends on discouraged? Short answer, Jeff, no. It's fine to document your dependencies in that way. And there we go. So with no more questions, I'm going to move on to plugins. Very good. Now there's another great set of documentation, and that's the Gradle user's guide that comes with Gradle. And currently in its chapter 22, it defines the list of standard Gradle plugins. Now those are plugins that come with Gradle. You've already got them. You don't have to do very much to apply them to your build. It's a single line of code. And there's a whole ecosystem of other plugins contributed by open source authors, by commercial product vendors. Inside your own enterprise, as you're building out your build framework based on Gradle, you are certainly going to create plugins of your own that are going to be distributed internally. We'll be looking at the standard plugins, and particularly the Java plugin. This is going to help us build some Java code in a very simple way. Now, there are some other language plugins right now. C++ is currently considered experimental. Very soon that won't be experimental anymore. There are plugins for integrating with Eclipse, with IntelliJ IDEA, for running find bugs, for running check style. If you have Groovy code, you can run the CodeNarc quality checker. Lots and lots of built-in plugins here. We're going to concentrate up top on the Java plugin, and let me give you an idea how this works. To do that, let's create a little bit of Java code. Get up out of this directory, and we'll go into a blank directory and make a little Java project. And I'm going to do this very quickly. Source main Java org Gradle poetry, and we'll call this poetry.java. It's going to be a single file, one line Java code, of course. Yeah, got a little excited there. I didn't want to make a directory called that. I just wanted to make a directory called that. And then we'll open up in here and make this Java program. So here we are. I will say we are in the org Gradle poetry package. Is that right? Yes, org Gradle poetry. And we can consider this a 100-person group pair programming exercise. So if you see me make any mistakes, just throw a comment in the question. So we'll make a class called poetry, and it'll have a public static void main method. And it'll have, let's see, we'll make another method called void, public list. Caesar, very good, and we'll make a list of strings here. So a very interesting little Java program. In fact, to make this easier, I'm going to grab this little Java program from somewhere else. And I'm going to copy and paste that in. You'd much rather me do that than watch me type all that, right? I can type that live, but it takes a while. So there we are. We'll import a couple classes, and this method called Julius Caesar is creating a new array list called lines, and then adding a bunch of these lines to it and returning that list at the very end. So it's going to return a little section of a play from Shakespeare. So down here we have the main method, and it will make a new instance of poetry. And let's see, we have Julius Caesar. We'll want to call that. And see, this class should also have a method called emit, which is going to take that lines list, iterate through it, and simply print out every line in it. All right, works well enough. And here we'll call P emit and pass the lines from Julius Caesar. So when we run this program, we should see it print out these, 16 or so lines of Mark Antony being upset that the conspirators just killed his friend. Good enough. Now that's great. There is our poetry.java program, and I'm going to come back here. I'm going to run a command called tree to show you the directory structure of this Java project. Source, main, Java. That looks familiar if you've seen, if you're familiar with the standard Maven directory format. And Gradle thinks that's just great. And then org, Gradle poetry, poetry.java. Very nice. What I need now is a build file, build.gradle. So we've got our poem, or rather our program written that spits out a poem. Now we need to do the difficult work of, here, let's think. What are the things we need to do here? We need a way to compile the Java code. We need to maybe run some tests. We need to copy static resources. I don't have any static resources right now, but I might need some in the future. That's something that my build might need to do. Run tests, format test results. We need to build a jar. We might need to tie all these things together, have some kind of a top-level task that does it all. That's kind of easy. We saw how to do that before. Does all of these things. So, oh man, we've only got 25 minutes left. That's an awful lot of work to do. So I don't know if we're going to be able to do it, but let me try. Apply plugin Java. That's actually all we need. So let's go back to our build here. I'll show you the tree again. We've got source, main, Java, org, Gradle, poetry, poetry. We've got a build file up here. I can simply run Gradle, and let me again run Gradle tasks like I did before to show you, suddenly having applied this Java plugin, I have all these tasks now. I have a task that compiles code. I have a task that builds a jar. Here's one that does all the compiling and copying of static resources. Here's a task that runs tests. If we were to introduce tests, here's a task that builds Java docs. This is great. I'll just run Gradle Build. That's kind of the total containing do everything Java plugin task. Here we are, built. Now, I'll clear the screen again. I'm going to show you the directory tree. Suddenly, we have build with classes. Here's our class file of our compiled Java code. It's built a jar for us. It didn't find any tests, but it tried to run tests and build some formatted output. It's done everything we need. So now I could build classes main if I wanted to do this in org Gradle poetry, a very pedantic way. I can run that program from the command line. And there you are. Man, that's great. Okay, so all that Java work done for us. Let's add a few more things. Number one, this whole business of command line Java, nobody likes that. Okay, that's just not fun at all. So I'm going to introduce you to a new kind of task definition, and that's a task with a type. Remember I said how tasks are objects and tasks have an API? Well, tasks being objects can also inherit from task types. And this is a documented task type that we could go into the DSL documentation and find, and it would tell us this is a task for running Java programs. So instead of all that command line class path stuff, and that's pretty simple because I don't have any external dependencies right now. If I wanted to bring in some external dependencies, my life would get harder. And I will in a minute. But here, I can just tell it, run Tim, run time, class path. I can just tell it, please go run this class, org, Gradle, poetry, poetry. And please, for your class path, rather than having to compute the -cp and figure out where everything is, and that's such a pain, I can just tell it, Gradle is automatically accumulating this list of all my classes, all my modules I depend on, and putting them there in that runtime class path variable. So now I've got this task called Caesar, And yeah, as I said, Caesar, C-A-E, there we are, compile the code and run it all from one place. So if I were now to go change my code, so if I took those commas away, for example, I could simply go back and run Caesar again. It's going to recompile that code. And we'll see the commas are gone in that line. Notice on that point, up here, Gradle's giving me this message that says the process resources task is up to date. Now, process resources is looking for a directory called source main resources. Now, you see, we don't have a directory called source main resources. We just have source main Java. So Gradle knows it doesn't have any work to do. That process resources task is just idle, and it's not bothering to rerun it because it knows its work is already done. In this case, I changed the Java code, and compile had work to do, so it didn't say that it was up to date. But suppose I run Caesar again. Gradle's going to say, compile Java's up to date, I don't need to do that. Not really saving us a lot of time in the case of this one file, but in a practical build context, that can be incredibly time-saving. And all of the default, or all of the standard plugins and the built-in tasks that come with them have automatic up-to-date checking in every case where up-to-date checking is appropriate. For tasks that you write, that do your own transformation, building of resources and copying of files and whatever it is, a custom task you write, there's an API for you to engage that incremental compilation framework. All right, I'll pause again very briefly just to make sure anybody who wants a question has a minute to get it in. Before we move on. All right. Now, most people are keen to understand how dependencies work with Gradle, and I would love to show you that. And let me briefly do that. It would be kind of cool if we could encode all this output rather than just dumping the text straight out, right? So let's think about how we might do that. I'm going to add a method to this class called encode. Encode takes a line of text, grabs a base64, a class called base64, and attempts to base64 encode that line of text and return a new string that's the base64 encoded version of the string that we pass in. So where does this base64 class come from? Well, naturally, that comes from the Apache Commons, the Commons Codec project. No better place for it, right? So let's go ahead and run this and see what happens. Of course, we should have automatic base64 encoding of everything, and it should be a wonderful world. We're going to go ahead and start up. We're going to compile, and we've got a compile error because the Java compiler doesn't know where to get that from. Of course, it doesn't because that class is not in our class path. How do we get it there? Well, Gradle is compatible with Maven-style repositories. So with the Java plugin applied, I can simply say I have a dependency. It's a compile time dependency on Commons Codec. And here we have the standard Maven group artifact version format dependency declaration. And I'm telling Gradle that it should hook this in to not just the runtime class path, but also the compiler class path. This is a compile time dependency because here in poetry.java, I'm including it. So Java C, as it's compiling this program, needs to have this class in its class path. So that's a compile time dependency. And repositories, here we are. Gradle is not going to assume that those should come from any particular repository. I could define potentially IV repositories. I could point it at a flat directory of files. If I just had a directory with all my jars in it, I could create it to point it to an on-site Nexus or Artifactory local Maven repository of my own. I could point it at my local M2 cache. But here, I'm just going to keep it simple and say, I would just like you to download this from Maven Central. And with that, we have an external dependency in our project. Now, it may or may not actually show the download happening. This is probably cached locally for me. So there we are. And of course, we created the encode line, but we never called it. So let's go ahead and actually call it. There we are. We're encoding each line. No, that's the wrong place for that. And again, we're pair programming, so I'm sure you caught that mistake and you were getting ready to tell me in the chat. But here we are in our emit method. As we iterate over all those lines, for each line that we emit, we will also encode it first. I'll go back here, clear the screen, run Caesar. And there we are. We've got base64 encoded stuff with that dependency already having been downloaded. So if I were still playing the game of trying to run this from the command line, and I was saying org, Gradle, poetry, like that, it would of course tell me that I've got a class not found. If I wanted that to work, I'd have to go here and somehow put Commons codec on my command line. Here, though, Gradle is taking advantage of firsthand knowledge it has of the build and saying, well, I know what's in your runtime class path. I'm just going to put that here. Suppose you had to, in a more practical context, create some kind of runtime deployment archive that maybe was a custom thing. Maybe it wasn't a war, it wasn't an ear, but it was work you had to do to bundle up these dependencies together. Well, you have access to this list of dependencies. You have access to this list. Now, Commons codec is a trivial thing, and it so happens that it does not have any transitive dependencies. It's just one jar that you get. But it's not too far that you have to reach into the world of open source Java before you have all kinds of transitive dependencies. What if you're downloading Spring Core or something like that? That's got, well, Spring Core is pretty lightweight these days. It's got like 4 or 5, but still it has transitive dependencies. And what if you want to access those and use them? Well, you've got this API inside the tool here where I could say configurations.compile as path. And I could say, would you please go print that out or grab this collection of files and bundle it into this custom zip file archive that I'm using that my production team expects to see. Since I am programming and I'm in really a development environment, this nice, clean declarative format is re-exposed to me as a readable API that I can see as a programmer. And I'll go ahead and take that line out. We'll not continue to be distracted down that path, but I want to make clearly the point that not only can we declare things easily, but we can later, in an imperative sense, access those things as if we were programmers. I see a few questions have appeared that scrolled off the bottom of the screen. One question from Ivan. How does Gradle know that when you run Gradle Caesar, it should run all these tasks? Because I didn't declare any dependencies, did I? Awesome question, Ivan. It's magic, but it's magic that's very carefully defined. And the bottom line here is that because I'm accessing this internal variable here called runtime class path, that's a variable in the Gradle domain model, Gradle knows how that thing gets populated. And it gets populated in 2 places. Number 1, from compile and runtime dependencies that I declare. And number 2, from the output of a task called compile Java. We've seen compile Java run when we run the build. Compile Java generates outputs. Those outputs are inputs to this thing. Gradle knows that, and so it auto-wires the dependency. In other words, it will figure out dependencies that are formally present even if you don't indicate them explicitly. So I could go depend on compile Java here. but it's not necessary. Gradle does that for me, and it does that in a formally correct way. Where did Gradle get the plugin from? Apply plugin Java. It's packaged with Gradle, the Java plugin classes, and a plugin is a class and a collection of other APIs and dependencies if needed. Those are bundled into Gradle, so I get that for free. When I'm introducing or when I'm asking for or applying a plugin that isn't a standard built-in plugin, then I need to provide some other help for Gradle to know where to go get that from. For example, I've written an open-sourced a liquid-based plugin that's available on GitHub, and for you to use that, and you can ping me later if anybody's interested in that as an aside. If you want to get to an open source plugin like that, there's a little bit more text you give it to say, hey, go get it from Maven Central, here's the group artifact version, etc. Dimitri asks, where does the plugin reside? Same question again, that's inside Gradle, inside the Gradle installation. Dimitri asks, can I distribute plugins via repositories and pick them up automatically during the build? The answer, Dimitri, is absolutely positively yes. Sangeeta asks, where is Maven Central defined? That's defined as a part of the Gradle DSL. So it's a feature of Gradle that it understands that Maven Central maps to the standard URL for Maven. Now, if I wanted to define other Maven repositories, there'd be another syntax that I'd use here that would look something like this, and I won't do that. I don't have that other Maven repository available to me, but I'm able to define other local Maven repositories if I don't want to use Central. If I just want to use Central, I use it like that. And we have one report from a few minutes ago of losing audio. Can I get a few people indicating whether or not you have audio? Okay, thank you, everybody. All right, this is a great project and groundbreaking. It's okay. It's a pretty simple project, but look at what we've seen here. We get this plugin that's built in that applies all of this conventional behavior. I don't have to be imperative about a single thing ever. I get all my Java build to work. I could go write tests, and I'd have a task called Gradle test that would run the tests, format the output, and do all that work for me. So that's really the right way to get large bulk amounts of functionality into your build and keep the build file simple. We've seen how to integrate with external dependencies. We've seen how to add tasks of our own. We've seen that tasks can have types, and with task types come the imperative behavior, the actual forking of a JVM and formulating of the command line and all that stuff that you got to do to go execute Java code. That's all hidden inside that task definition, inside Gradle itself. And then I have declaratively just the few parameters, the minimum number of parameters that I need to make that task do the thing I want. And it turns out, if you look in the DSL docs for Java exec, there's a rich API. There's a couple dozen properties. I can set the input stream, the output stream. I can set heap parameters. Anything I'd want to do with a JVM, I can set. And those are all just declarative parameters, not imperative things. So that's pretty great. I'd like to translate this. A question quickly from Santi. Do we need to worry about things like Maven lifecycle, phases, goals, etc. with Gradle? And the answer is no, you don't. Activity is organized into tasks, and tasks are the things that get executed. Dependencies are computed by Gradle such that all of the things that need to run based on the dependencies you've defined, those things run. So there isn't any kind of specific or rigid life cycle that a build has in Gradle. It just doesn't exist. So you get to define the idiom of your build and the language of your build by defining those tasks rather than conforming it to the life cycle phases that some kinds of builds have. Now, the Maven lifecycle really isn't like it's some bad idea or somehow harmful. It's a really good idea and a really strong set of activities to divide a build up into, but only certain types of builds. So for the builds for which it makes sense, it makes all kinds of sense. And some of the smartest builders that we have identified those life cycle phases for us to use. But your build might not look like that. So Gradle doesn't want to want to force you to have to fit your build activities into that sort of thing. It would rather say, why don't you just define your tasks as needed and express your build activity in that way. All right, I'm going to go ahead and close this down. We'll save that file. I'm going to close this, and we'll save this. And we're going to go up into a multi-project build, which is, for the most part, already put together for us. And I'll show you roughly what that looks like. So let's see if we can get the tree here. Here we are. Here's the tree of this project. I'll start at the bottom. I've got source, main, Java, COM, no fluff, poetry, a different packaging system there. But here's this top level project called the poetry emitter, this class here. Then I've got a sub-project of content. All right, and this has a single class called poetry that generates the content, and I've broken my codec stuff into another project, the codec sub-project. So let's take a look at how these individual pieces work, and I'm just going to open this up as one big project, and we will quickly work through this. It actually won't take us long to build this whole thing in the time we have remaining. So here's our top level kind of command line driver or program that runs all the other programs. Our main method still looks into this poetry class for content called Julius Caesar and tries to emit that. The emit method is right here in the poetry emitter, a good place for it, but it expects this codec object to be present to be doing the encoding. We instantiate that codec object right here. But codec isn't here, and worse yet, poetry isn't here. Those are in sub-projects. So over here we have our sub-project called content that introduces this poetry class that does what our other Julius Caesar method did. See there, it just spits out all those lines. And we've broken out the content, or pardon me, the codec stuff into a class of its own, in a project of its own. All right, now how do we put all that together? Well, the way we do that, and I'll walk you through this build, we can do this actually in a single build file. So I'll take you to this block here called all projects. All projects in a multi-project build defines a block where we're giving configuration that applies to all of the projects in the build. So we're saying all of them are Java projects, and if any of them needs to go get dependencies, it should get those dependencies from Maven Central. If we jump down here to line 14, I'm able to define configuration for the content sub-project. Just this sub-project on its own, just the content guy with the poetry class in it, I'm saying, well, it has a dependency on JUnit. It's going to run some tests. Down here on line 20, I'm saying I would like to define some configuration that applies only to the codec project. So the codec project itself has a dependency on Commons codec, just like we saw before. Now, notice what's a little bit surprising about this. This way of configuring the build doesn't have a build in the codec directory and a build in the content directory. It has one top-level build that does all that work all by itself. This is just one way of configuring a multi-project build in Gradle, and I'm showing you this to illustrate something very, very important. That's that as a multi-project build in Gradle, I have a means of accessing all of the other project builds in the project graph. So from the top level, I'm able to specify configuration that my sub-projects should have. And in some cases, that might be very important. For example, you might want to say, well, all you sub-projects, you're only allowed to use our internal Nexus repo as to resolve your dependencies. You can't define any other repositories, and if you do, we'll fail the build. So you want to be able to reach down into project codec and project content and see how have you done this and make sure they're doing things in the right way. Alternatively, I could take configuration like this, dependencies in this codec file, and factor it into a build file that lives specifically in that codec directory. So with Gradle in a multi-project build, I have the option of having this kind of radically unified build with everything in one place. I could have a radically ununified build where all of the sub-project configuration is at the sub-project level, or I can decide to factor that configuration between sub-project and top-level project in whatever way I want. It's a completely programmable model, and all of that task configuration is available to me from here. And I had planned on, let's see, what are my, got poetry as my task here. I had planned on having to tweak this code a little bit to get everybody familiar with how it's structured. We'll see if it works on first run, and you see it's now building. Wonderful. It's compiling Java in the codec project. It's compiling Java in the content project. Now at the top level, it's compiling project. It's running the poetry task, and it spits out all our encoded poetry again with this multi-project module. I see there are a few questions here. Let me make sure I take those. Is it possible to keep, Paulo, is it possible to keep import dependencies from a pom.xml file? Yes, there is a community contributed plugin or a Maven integration plugin that will allow you to import dependencies from a pom.xml file. Why don't you go ahead and reach out to me after the webinar and we can talk about details of that offline. Does the Java plugin, Patrick asked, does the Java plugin point to Java Home, or is there a Gradle config? There are a number of Gradle configurations, and I'll point you briefly. I'm here in the DSL documentation. I would scroll to task types, and I would go to Java exec, and then I would feast on the rich library of configuration parameters that I can give Java exec that tell it exactly where to go for all that stuff. So Patrick, Java exec is deeply configurable for running that Java program. Ivan asks, does the subproject name in the Gradle build file depend on the subdirectory name? And the short answer, Ivan, is yes. That's the most convenient way to make that reference. We're right at the end of our time. We've pretty much gotten through all the things I wanted to be able to show you. I wanted to give you some of Gradle's philosophy, why it's being another build tool, why it values declarative over imperative, and why it sees tremendous value in build configurations, but also really wants to make it easy for you to customize your build. We took a look at the basics of Gradle tasks. I showed you how to use the Java plugin in a very simple way, and how to convert that Java project into a multi-project Java build or a multi-module Java build, and a little bit about how the Gradle API interacts with multi-project builds. There's much more to say about multi-project builds. There's much more to say about plugins, about other little corner cases of the Java plugin and the APIs it exposes. There's really lots to talk about there. Particularly in the topic of plugins and build customization. That's stuff that really gets me going. I just get totally excited about that because that's where the magic of Gradle happens. The magic of Gradle isn't in building simple projects like this. The world already knows how to build things like this. It's good to know the Gradle idioms for simple projects, but the rest of the world is composed of profoundly customized, increasingly highly automated, very complex builds. And it's in Gradle's plugin API that you really start to get a handle on how to tame that complexity, how to write a bunch of high-value custom build software for your organization, but then expose it to the developers who use it with a very simple domain-specific language exposed in terms that all of your developers understand. So this is the stuff, again, that really gets me going in terms of Gradle. So thank you very much for being here. You guys, I'm going to stick around for a few minutes and answer your questions, but I'll say for now we are officially concluded, and I thank you very much for your attendance. We'll follow up with you by email and give you some additional resources. So thank you very much for attending, and we hope to talk to you soon.